So now we'll study the theory of the ellipse. The ellipse is a part of a coordinate geometry. Now in the parabola chapter we studied how the ellipse is derived from a double cone and how its equation, or what are the conditions for the eccentricity and all. So let us study ellipse and its properties. Now the definition of an ellipse. An ellipse is the locus of a point in a plane which moves such that its ratio of its distance from a fixed point, which is a focus, and the line directrix is less than unity, which means the constant is less than 1. And again the standard equation of an ellipse is x square by a square plus y square by b square equals to 1, where we take this axis, when the axis means, we know that we'll study in an ellipse that there are two axes known as the major axis and minor axis. The major axis is the x axis and the minor axis is the y axis. So it is the standard equation derived in such a way, with the major axis is x axis and the minor axis is y axis, and e square equals to a square minus b square by a square. Now we'll study the terms like the vertices. The points A and A dash where the curve meets the line joining S and S dash. They are the two foci in the ellipse. So another important thing, we might not have noticed that in parabola there are only one foci, and from ellipse and hyperbola there are two foci. So we can say that this is one of the foci and this is directrix. So there are two directrices and two foci for an ellipse and hyperbola. And we can derive the equation of ellipse either by taking this foci and its corresponding directrix. We cannot derive the same equation by this foci and this directrix. You cannot do that. So take the foci and its corresponding directrix for deriving the same equation. Now again, the major and minor axis. The distances A dash, either A and A dash are on the major axis, means the x axis here. The B dash, the y axis, are the major and minor axis distances, and which are 2a and 2b, like this is the b and b. So if we solve this, we get this as the 0, minus b, 0, b, and like that. So when we'll calculate, it will be 2a and 2b. Next, the focal chord. Again, any chord for passing through focus is known as a focal chord. This is a general term which we'll be using in every conic. Directrices, here there are two directrices, that's why we mentioned this point. Zk and z dash k dash are the two directrices, and their equations are x equals to a by e and x equals to minus a by e in the standard equation. Center. A typical definition of center can be a point which bisects every chord passing through it. Just a small and typical definition. So if we take any chord, then it is a point which bisects it. So there might be different points which will be bisecting that, but if any chord passes through the center, then it is a point of bisection. Next, the ordinate and double ordinate. If from any point P on the ellipse, if perpendicular is dropped on the x-axis, meeting at N on the x-axis, diagrammatically P, N. This is known as the ordinate, and we extend the Pn to the ellipse to cut it as P dash. The P and P dash is the double ordinate. So these are the one different term here, double ordinate. Next, the double ordinate passing through focus is nothing but a lattice rectum. So here, when the double ordinate passes through the foci, it's known as the lattice rectum, and the length of the lattice rectum is 2b square by a. We need to remember the formulas. For standard equation, its length is 2b square by a. And let us study some new terms. Focal distance. Here there are two foci. So here the focal distance is defined as the sum of the distances from the two foci to the point. So if this is the P, S and S dash, the distance SP plus S dash P, if you derive S dash P, it is a constant and it's nothing but 2a. So it's a very important property and we need to remember that. Next, we can also derive the equation of ellipse referred to as two perpendicular lines. How? So there are some corrections here in the formula. So let us take two lines. This is the point P. If you assume this as Pn, this as Pm. This is Pn and this is Pm, and this is L1 and this is L2. Now if it assume that the point is Px, y and P1 is distance from the line L1, so this implies it is P1, and we will assume that the distance from the L2 is P2. Then L1 is A1x plus B1y plus C1 equals to 0, and L2 is B1x plus A1y plus C2 equals to 0. Then the equation of the ellipse can be said as P1 is P1 square by A square plus P2 square by B square equals to 1. So here what Actually this is the points we have. So we'll just compare it. The P1, we know from straight lines chapter how to calculate the distance of a point. Distance of a point from a line. So we'll use that one. Here we are using the perpendicular distances. Then we will substitute P1 by A1x plus B1y plus C1 by root of A1 square plus B1 square from the straight line chapter. This is the distance P1. Similarly B2, we'll get this as the equation. So actually in the questions how they will give as, they will give the equation of the ellipse in such a form. Sum of the two square quadratic terms, or in the other manner like in the straight two different line terms. So we directly on seeing that equation you strike that yes, this can be a possible case of the equation of ellipse referred to as two perpendicular lines. So check whether the two lines are perpendicular. You know that the slope should be product of slope should be -1 if it satisfies. So you can definitely say that it's an equation of ellipse referred to as two perpendicular lines. So let us study some other properties of ellipse now. Now we'll learn how to determine same which you studied in parabola, circle, and studying in every conic, to determine the position of a point, whether it's outside the ellipse, on the ellipse, or inside the ellipse. So again we will using the S11 here. S1 for here it will be x1 square by a square, y1 square by b square minus 1. So actually the equation is x square by a square plus y square by b square minus 1 equals to 0. So substituting the point x1, y1 from x and y, will get the S11. So if it's greater than 0, implies the point is outside the ellipse. If it's less than 0, implies the point is inside the ellipse. But if it's equal to 0, the point is on the ellipse or on the circumference of the ellipse. Next, now in the ellipse we will study the parametric coordinates and its equations. Now here we will derive it in a different manner, not like the other conics. We assume a point on the P, which is the x comma y, let us assume, and you have to understand that there is a new circle known as auxiliary circle in ellipse, and its center is the same as of the ellipse, but its radius is the semi-major axis length, which is a. So it will be of this form. And now what we'll do is we'll draw up a perpendicular from P on the major axis, denote it as M, and if we extend MP, it will cut the auxiliary circle at Q. So the angle Q, if this is a center CM, so actually QCM, we'll assume it as psi. Then psi is nothing but the eccentric angle. An important term here which you are using, eccentric angle. So the angle ACQ equals to psi. Now you know that these points is a cos theta comma a cos psi comma b sin phi. From that we'll derive this. The derivation is not required here. You have to remember that for an ellipse it will be a cos psi and b sin phi. Just replace the a by b here because it's an ellipse. The derivation will be not shown here. So these are the parametric points, and you have to remember it. They are very important. Like in many number of questions and deriving the tangent equation, normal equation, we use the parametric points. So it's very important. Next, we denote this point a cos psi comma b sin phi is denoted by p of psi, which means the x coordinate y coordinate with the eccentric angle psi. The equation of the chord joining the points p of alpha and q of beta is given by x by a cos of alpha plus beta by 2, y by 2 sin of alpha plus beta by 2 equals to cos of alpha minus beta by 2. Very important equation, and we need to remember that. Diagrammatic way, this is p of alpha, q of beta, and the equation of the chord. Next, tangent to an ellipse. The equation of the tangent to an ellipse in the slope form is given by y equals to mx plus or minus root of a square m square plus b square. And the point where the tangent touches the ellipse is plus or minus plus or minus a square m by root of a square m square plus b square, comma plus or minus b square by root of a square m square plus b square. So if you take plus here, we have to use plus and plus here. If you use minus here, you take minus and minus here. You cannot use randomly here plus here minus here plus here. We'll get the point and all. Actually, it use in a proper way. Here it is plus or minus, again here it is plus or minus. So you take the upper part or either the lower part. You cannot mix both of them. At point x1, y1, the tangent to an ellipse is given by xx1 by a square plus y by 1 by b square equals to 1. Next, if you want to calculate the if you want the equation of tangent in a parametric form, just replace x1 y1 by a cos theta and b sin theta. We'll get the equation of tangent in parametric form as x cos theta by a plus y sin theta by b equals to 1. The point of contact is a cos theta comma b sin theta. Next, the number of tangents to a ellipse. if the point is outside, the two tangents can be drawn to an ellipse. If it's on the ellipse, one. Inside, no. How? When we'll scale this equation, we'll get a quadratic equation in M. So we can say that the maximum possible values of M are 2. So either the real values can be 2 or 1 or 0. So depending on that condition, when we derive, we'll get that for two tangents to exist, the point should be outside, and for one tangent, point should be on the ellipse, and for no tangent, the point should be inside the ellipse. So here we conclude the theory part 1 of the ellipse. Let's start the second part of theory of the ellipse. Now, if you know a point x, y1, if it's like outside the ellipse, then two tangents can be drawn. Then the combined equation of the tangents is given by s1 square equals to s3 plus s1. So we're thinking the point on this, what will happen? We know that the point is on this, s11 will be equal to 0. So this equation will turn s1 square equals to 0. It's nothing but s1 square will be equal to 0 if the point is on the ellipse. Which implies s1 equals to 0. We know the tangent is also given by s1. Next, again, when two tangents are drawn, the point joining these two is known as the chord of contact, and again it's given by s1 equals to 0. Next, here again the director circle comes out. The locus of the point of intersection of the perpendicular tangents is a director circle, and in case of a standard ellipse, it's x square plus y square equals to a square plus b square. And to be correct for defining for all the ellipses, its center of the director circle is same as the center of the ellipse, but its radius is root over a square plus b square. So we can just remember it is the point of intersection of perpendicular tangents. Next, normal to an ellipse. The point form, like if it's the x1, y1, the point form equation of a normal is given by a square x by x1 minus b square y by y1 equals to a square minus b square. Important formula, you have to remember that. And again, at parametric point, a cos theta comma b sin theta is given by a secant theta minus b y cosecant theta equals to a square minus b square. And if we get the slope of the normal as m, we get in the slope form it as y equals to mx plus or minus m into a square minus v square by root over a square plus b square m square, and the points at which the normal touch is plus or minus a square by root over a square plus b square m square, comma plus or minus b square m by root over a square plus b square m square. And if any normal at p meets the major axis and minor axis at g and g, so if this is p, this is g, this is small g, so drawing it again, this is p, this is capital G, and this is known as small g. Then some conditions are derived, which are here if CF is perpendicular upon this normal from the center, so this point is F, PF into PG equals to B square, a constant, and PF into P small g equals to A square. So here we are telling the small g and capital G, you have to carefully see PF into P capital G equals to B square, PF into P small g equals to A square. So you can diagrammatically you can see there. Next, P small g into P capital G equals to SP into S dash P, the product of the focal distances, and CG into CT equals to CS square. So these are the four conditions which are derived for normal. Next, we'll study about the possible number of normals and conormal points. And if we square the equation of a normal, and if we substitute it in the ellipse, because the points exist on the ellipse as well as on the normal, we'll get a fourth degree equation. So we can say that a maximum of 4 normals can be drawn from a point to an ellipse, and the points from which the normals drawn pass through they are known as the conormal points. So again, now we're gonna study some properties on eccentric angles of conormal points. So we'll draw a diagram for that. This is an ellipse. The eccentric angle of conormal points, CP means conormal points of an ellipse, at theta 1, theta 2, theta 3, theta 4. Then the sum of the eccentric angle, that is the theta 1 plus theta 2 plus theta 3 plus theta 4 is odd multiple of pi. So we need to remember that it's an odd multiple of pi, means 2n plus 1 into pi. Next, sigma of cos of theta 1 plus theta 2 is 0, and sigma of sin of theta 1 plus theta 2 is 0. These are the important points. You can remember them. They can be useful for calculations of questions. And if you take it some point form like x1, y1, x2, y2, x3, y3, and x4, y4 are the 4 conormal points. Then x1 plus x2 plus x3 plus x4 into 1 by x1 plus 1 by x2 plus 1 by x3 plus 1 by x4 equals to 4. So these are some some of the conditions we studied, these can be remembered. Now, like in the reflection property in a parabola, now there is also a reflection property in an ellipse, which says that if a ray passing the one of the focus get reflected from the ellipse, it passes through the other focus. So it's a very important property. Similarly, they can say that the elliptical mirror is given, a ray is passed, and they will not even directly tell that it passes through the focus. They just give the equation of the ellipse and the equation of line. On solving, if you understand it passes through the focus, then you should directly strike that it will pass through the other focus after reflection. So just find the point of interest from the line and the ellipse. This point you will get, the other focus. Just find the equation of the line join these 2 points. So the question is easier. So such type of points are very useful, and these need to be remembered for solving some of the questions, or else you will not understand elliptical mirror, what we have to do. Then you'll start drawing the normals, the point of intersection, and doing the law, apply the law, like law in incident ray equals to angle of incidence, angle of reflection and all that, but it will take a long time. So better remember this formula. Next, again, the equation of chord bisected at a point P of x1, y1, we are studying in each and every chapter, is given by s1 equals to s11. Next, pole and polar. We need not define what is the definition of polar again. Point P, number of infinite sequences are drawn. The point of intersection at the tangent at the endpoints is nothing but a straight line, which is nothing known as the polar, and its equation is s1 equals to 0 again. Now we'll study conjugate points, a new term. 2 points are known to be conjugate points if each lies on the polar of each other. Like if we take 2 points, this one and this one, if its polar is this, and if its polar is this, which means not the same, like which means that the polar of this passes to this point and the polar of this passes to this point, then the 2 points are known as the conjugate point, and the 2 polars are known as the conjugate lines. And again here, the diameter of an ellipse, we know that the diameter for any conic is nothing but a locus of the midpoints of system of parallel chords. So here, if we the parallel chords slope is m, the equation y equals to minus b square x by a square m, and the 2 diameters are known as the conjugate diameters if each bisects the parallel chords of the other. So if these are this is one of the diameter, and if we take another chords like this, such that this diameter bisects the other chord too, then they both are known as the conjugate diameters, and the condition is m1 m2 equals minus b square by a square, and m1 and m2 are the slopes of the 2 conjugate diameters. Next, important point which might be used in questions: if the eccentric angles at the ends of conjugate diameter points, CD means conjugate diameters as we have referred here, differ by 90 degrees, then the sum of the squares of any 2 conjugate diameters, which means the length of the conjugate diameters, equals to a square plus b square. So it's a very important property, try to remember it. And another point, the tangents at the endpoints of that conjugate diameters form a parallelogram of area 4AB. So tangent drawn, again a tangent drawn, it will form a parallelogram in some manner, and its area equals to 4AB square units. So sometimes they might give the equation of the ellipse and directly tell that the tangents are drawn at the endpoints of the conjugate diameters, find the area of the parallelogram. So we're thinking where the conjugate diameters are drawn, infinite conjugate diameters are possible, what will be the area? But you need to remember such type of points. So we told some points are very useful in solving some of the questions directly. And so here we conclude the theory of the ellipse. In the next video we will be solving the questions of the ellipse. So the question will be quite easier again, because in all the coordinate geometry we just need to remember some of the formulas, the basic knowledge. So you just read the question, understand them clearly, you will be easily able to do them. In some of the questions the calculator might be a bit lengthier. Just solve them with patience and slowly, and don't emit the calculation mistakes.